Just starting to finish up the calculator series here, so I think I'll have one more video after this one, but I threw in volume, energy, and power. You'll notice volume, the units get a little weird when you're talking about meters cubed and liters and centimeters cubed, because technically a meter cubed is just a meter cubed. A liter is actually a decimeter cubed, same thing. And then a centimeter cubed is just another derivation of this. So I try to avoid doing like a base unit and then the centi of that base unit and then the deci of that base unit. But cc's are very common. Someone will say in the medical field, they'll be talking about cc's. So that's a cubic centimeter. So I figured I'd just throw it in there. And then liters are obviously very common. It's the same thing as a decimeter cubed. And then meters cubed, I would be doing an injustice by not throwing that in there. So gallons, liters, meters cubed, feet cubed, and centimeters cubed. I didn't do inches cubed for the same reason that I'm just trying to explain there. I want to make it clear again, the only reason I'm including centimeters cubed is because it's a common unit. Energy is also a bit different. Most of the time you'll hear it in terms of joules. You may hear it in terms of calories. That's actually what calories on your food mean, how much energy is in there. But a food calorie is actually 1,000 times this number, but it's called a kilocalorie. The calories you see on your food labels they'll be written as calories, but what they really mean is kilocalories. These calories are the base unit of calories. Then you'll have something called an erg. Pound force, you guys have probably dealt with torque before. Torque is measured in pound force. That is the same as saying a joule or a kilowatt or a calorie or an erg or a BTU or an electron volt. But it's easy to represent torque in pound force because or foot pounds rather. It's easy to represent it because you're multiplying the feet of radius times the force applied. That's why torque is generally expressed in pound force. BTUs are just British thermal units. Not really a big fan of them, but they're common enough that I need to show them. And then EVs are electron volts. They are used in a lot of electrochemical calculations. So like I said, this whole thing is just any conversion of those. And then power, it's kind of a fun trick. I could have had the same thing up here as down here, but power is literally just energy divided by time. So you would divide kilowatts by hours, you would divide calories by seconds, erg per second, foot pound per second, BTU per second, EV per second, joule per second. Any energy unit per time will get you power, but because I've supplied all of the energy conversions up here, I'm only using the common power units down here. So you'll typically hear power expressed in kilowatts, horsepower, and BTUs per second. If you have something in ergs, just convert ergs to joules or BTUs or foot pounds or whatever will fit down here, right? And then excuse me, if you have energy in joules, you could utilize the fact that a joule is a watt rather is a joule per second, and then you could go right into kilowatts. But nevertheless, you could always just convert back to your kilowatt hours, to your BTUs or whatever. And then horsepower is a bit different. It's just how we measure power on this side of the world. But yeah, just a quick addition to the calculator. Again, this isn't the last video, but in the last video, if you're interested, you could just skip to the very last video. I will have a link to my Patreon under all of these, but I'll have the final chemical engineering or process engineering handy calculator, and you can go to my Patreon and purchase it there. Again, thank you for your time, and I hope this calculator either inspires you to make one yourself or gets you to go and purchase this one. Either way, it is a useful tool, and it'll prevent you from having to do a lot of redundant and rudimentary calculations. Thanks again.